This is actually where it's more interesting, where you can't actually go there. So as an example, I want you now to consider this one. The limit as x approaches 2 of this. Okay, so think about this with me. What is this? What is this thing? If I asked you to graph this, you have enough knowledge now that you can graph this. One of the things that should stand out to you is the denominator. What does the denominator tell you about this graph? Now, I heard at least two different things there, one of which was half right and one of which was more accurate. What this implies is a domain restriction, right? X can't be equal to 2 because you can't divide by 0. You can't divide anything by 0, okay, because our numbers blow up. Okay. By the way, one of the reasons why you can't divide by 0 is because of this. As you get closer and closer to dividing by 0, you don't get any sensible value. Like from one direction you go this way, the other direction goes that way. So there's not one value we can all agree on, unlike this. Okay. But coming back, 2 is outside the domain. Okay, or I should say x equals 2. Now the other thing I heard was a vertical asymptote. But there is not a vertical asymptote if you go ahead and draw this thing. Let me show you why. Let's write and work with this thing, okay? This is a bit of a pain, but I'm promising you now, this is a problem that all Year 11 students do when they meet this topic. You're considering this function at a particular value, or as it approaches a particular value. And this has to be continually stated every time you work on this thing. So you have to restate this for every line where you do some working. And people often forget to do that. I hope you can content yourself with the fact that the limit as x approaches something of the function is not just the same as the function. Okay, those are two different things. One is a function and one's just a number. Okay, so you have to say this over and over again, which is a bit of a pain, but trust me. So I'm going to look at the numerator and notice that I can do something with the numerator that helps me simplify things. What can I do? I can clearly factorize, right? Your factorization, of course, is going to be x minus 2x plus 2. There's my numerator, and then I have a denominator. Okay. Now, at this point, I'm going to make you notice that if that x minus 2 is there, then that means we have this domain restriction. So x can never equal 2. It's outside the domain. Okay. Which means that here, because I have this on the numerator and the denominator, x minus 2, remember, it's variable, right? Depending on what x is, x minus 2 can change its value. But you can tell me, based on this, what x minus 2 will never be equal to. What will it never be equal to? It will never be equal to 0. So therefore, I can multiply the top and bottom, or rather, I can divide the top and bottom by this, because I know whatever it's going to be, it'll never be 0, right? I can even state it right here. It flows directly through here. You see I just subtracted 2 from both sides? Okay. So seeing as x will never be 2, x minus 2 will never be 0, I'm going to divide the top and bottom by that, because it's not 0, so I don't care what it is, it's fine. So therefore I get this. Write the limit again. Don't forget to write the limit. You just get left with this. Now, what this means is, this is just like the first example, where you can literally just put in the number. You can evaluate when x equals 2 here. There's no problem with that, right? As long as you remember, x can't actually be 2. I'm just thinking about how close I can get to 2. What's it equal to? 4. So what does this look like? Draw this with me. This is what the graph looks like. Remember, as we went through our simplification, at one point this was rewritten as this. Yes? What does that look like? Y equals x plus 2. What is that?
It's a straight line.
It's just a straight line, isn't it? It's going to go through 2 and negative 2. Okay. I'm going to draw, what am I saying? That's 2, something like that. I'm going to draw this part of the line. Right? That's what x plus 2 looks like. Except when x equals 2. When x equals 2, I'm not meant to exist, right? So how do we indicate when something doesn't exist? When you exclude a single point, what do you do? It's a hollow circle, right? like that.
Is that where L'Hopital comes?
Sort of. L'Hopital's rule has many more broader applications than just this. And actually there are some conditions of using L'Hopital's rule that we haven't explained here, so be careful with that. L'Hopital's rule was one of the easiest things to misuse in all of calculus because it's a cool tool that has conditions that people often don't pay attention to. So just be careful. X can't be 2, but then after that, he just keeps on going on his merry way, right? Like that. So it's a straight line with a hole punched in it, okay? Because x equals 2 is outside the domain, but for all other intents and purposes, and go ahead, sub in some values, you will find that x squared minus 4 on x minus 2 behaves exactly like x plus 2, except for right there, okay? So no vertical asymptote. Do you notice that? No vertical asymptote, because everything just kind of simplifies out nicely. It's just that there's a hole. So there's a domain restriction without a vertical asymptote. Okay, yes?
Is x squared minus 4 and x minus 2 intercept that 2 as well? Minus 2, sorry.
You mean over here?
Yeah, would the x intercept be minus 2?
Would the x-intercept be minus 2?
Yeah.
Well, let's think about it. How do we find the x-intercept? You let y equals 0, right? So you're going to say, okay, I'm considering this right now. Like that, okay? So I'm going to let y equal 0, like you suggested. Like this. Now what do? I suppose I can multiply through by x minus 2 because it doesn't matter what the denominator is. So you end up with this. You already told me how to factorize that, right? So I'm getting this. So tell me what the solutions of this are. It's x equals negative 2 and x equals 2. However, you've already told me that x can't be 2. So therefore, the only valid solution that you get out of this is negative 2 only, right? Just like this guy, right? You see, these guys are mirror image of each other, not even mirror images, like parallel universe versions of each other, except for that part there. That's the only difference between them, okay?